starting off, we have Pat Martens from Bridge Preservation Inspection Services and talking about evaluating the root cause of deficiencies in rigid cementitious concrete overlays.
Yeah, my name's Pat Martens. I'm with Bridge Preservation Inspection Services, and I work as a consultant out of Jefferson City, Missouri. My experiences in bridge preservation go back about 40 years. I've been in bridge construction, bridge maintenance, bridge inspection since the early 1980s, I guess. So I wanted to talk a little bit today about deficiencies in concrete overlays. And I don't know really what the lay of the land is in the West as far as what kind of rigid cementitious overlays you may use in your particular state, or if you even do use rigid cementitious concrete overlays. I guess from a vendor, producer side of things, we always like to think our product is the best product, and we always like to think it works very well. And I think what you find, probably in talking to all the vendors here, is they do have very good products, and they do work very well. RCCOs, let me just abbreviate it that way, or dense concrete overlays. They've been around a long time. Over 50 years. Latex concretes have been out there since the late 60s. Silica fumes, low slumps, those have been around. I know I remember putting some of those in back in the early 80s. States developed their own mix designs. So there's a lot of variations of these concrete mixes. And what we find is they really work very well. The problem is occasionally you get some that don't work so well. And it's easy for agency people to get pressed about seeing, you go out there and you see all kinds of cracks, or you see spalling in your overlays. And you want to say, it doesn't work. Well, no, I think what you need to do is you need to go back and find, okay, what is the root cause of the issues that you have? And the thing about concrete is it can be pretty tough to decipher and determine just what is the root cause. Or it could be a number of things that's contributing to the issues. So we like to have these good-looking surfaces, but occasionally we get some that don't work so well. Now, I don't know how many of you remember Colombo. You remember old Peter Falk he's back from the late 70s, early 80s. Dick does. Anybody else remember Colombo? Okay, it's a few of you out there. Yes, I'm kind of showing my age, but just to kind of show you where I'm at in my life. Saturday night, I'm watching Colombo on TV from 40 years ago. So I was watching one episode, and Colombo basically, he solved this case by, he found a discarded piece of chewing gum in a trash can. He was able to take that and determine that the killer had deposited this chewing gum in the trash can, and he could take the bite mark out of that chewing gum and match it to the killer. So that's how he solved the case. Now, what does that have to do with rigid concrete overlays? Absolutely nothing. But sometimes you have to be like Colombo out there, and you have to try and root through the evidence and try to determine, okay, what is causing our problem? And not just write it off and say, the product doesn't work. Because we've got tens of thousands of concrete overlays out there that are in service. They've been in service for a long time. I've seen concrete overlays out there that are 35, 40 years old still performing. You have to go to the root cause and find out, okay, what is causing the problem? So my outline, I'm basically going to talk about two types of deficiencies, debonding or spalling. I kind of lump those into one, and cracking type issues. There's also scaling and other surface imperfections, but I'm going to kind of skip that just for the sake of time, because really I probably have about an hour of information here and I got 25 minutes. So I'm going to get through as much of it as I can here. So let's talk a little bit first about debonding and spalling, because I think that's a little bit easier for us to kind of wrap our arms around. There's really three things you're looking for as far as locations for spalling, debonding type issues. One, is it going to be down in the original deck under the overlay? Is it going to be at the interface where you attach that overlay? Or is it going to be in the material itself, that rigid material itself? And generally it's not going to be that third one. It's going to be probably one of those first two. So if it's below the interface, it's going to be an issue with one, either microfracturing, and that could be something that was just missed at the time of construction as far as trying to get out any delamination there. Or it could be something that we actually put into the deck just by our deck repair operations, such as using jackhammers, because jackhammering can induce vibration into the bars and cause problems with delamination. There could be other delaminations out on the deck that were just unaccounted for with the repair operation, and there could be patches that maybe have debonded or delaminated, and we need to get those out of there. So there could be issues with poor compressive strength in the concrete itself, and that's something you'd hope you would find maybe up front in the scoping process if you're doing some pull-off testings or things like that to try to check the compressive strength of the concrete within the deck. And then there could be just instances where you have damage that's been inflicted by maybe impact or something with joint problems or something of that nature. Now, if it's at the interface, it's going to be an issue with either the profile or the texture that we're attaching to. The more amplitude you can get in that surface profile, the more mechanical grab you can get out of the overlay system. Preparation could be as far as just not doing a good job of preparing the surface prior to the overlay, or an issue with contamination that's been put onto the deck surface. And then there's also the potential that you could have failure plane kind of self-induced by what you do as far as if you're going to use a bonding grout on the surface prior to the overlay, and if that's allowed to dry out, that can then lead to your debonding. Or if you get too much water out on the deck, that can also serve to be a failure plane for you. And then within the overlay itself, it's probably going to have to do with the material quality, mixing, placement procedures, things like that. So just a few pictures to kind of highlight some of that. Here we have a deck, fairly new. You got a big spall out in the center of the span. Hate to see that. You know, you hate to walk away from your project and then here in a couple months out, you got a big spall out there. But, you know, researching this, here we have a failure that's occurred at the rebar line, most likely just an area that was missed in construction. And this happened to be an overnight job, so it's something I had to get in and do very quickly. And, you know, you get rushed, you get in a hurry, you got to get it covered up because you got to get it open to traffic before you incur any liquidated damages or anything like that. So that becomes something you have to work around. This one here, can't get a good view of it, but I think it's more of a debonding issue. And the thing I wanted to highlight here was if you look closely, there's kind of a longitudinal joint there. It's a construction joint, so a stage construction. And this is kind of what we would see a lot with early age type of delamination or of an overlay. Would be at these types of joint areas, be it a construction joint or even a expansion joint area, because it's a lot harder to clean those areas. It seems like out within that span, you can do some pretty good cleaning, but then when we get to the edges, we seem to kind of skimp on that a little bit or don't put as much detail into that, and I think that's part of the problem here as far as this particular failure. Here we just have some a patch in the existing deck that's delaminated. You do want to make sure you're going through and sounding the deck no matter what your preparation method is, if it's just a milling or if it's a hydrodemolition type preparation. After you perform those operations, you do need to make sure you're sounding to verify that you are indeed getting all the material out. On the right, there's kind of a zoomed in photo. If you look real close, you can see a fracture of concrete in there that's kind of trapped by the rebar. Just little areas you want to get out of there. Kind of the point I wanted to make here, though, was the nice thing about these concrete overlays is they are structural overlays. You know, they're structural concrete. And they can, if you have fairly small D-lams, maybe fist size or less, they can basically entomb the deficiency there. So a lot of times you may have some very minor D-lams in there, and the actual overlay itself may, for a period of time, keep it contained and entombed in there so it's not spalling out. That's not what you want necessarily, but they do have the capability to do that. It kind of depends on the nature of the delamination, the depth, the size, and traffic considerations, vibrations, and things like that. Just a few shots. This is just failure areas that occurred near joints. Like I said, those are areas you do want to kind of focus on in your cleaning when you're out there as an inspector. And this another joint area, an armored joint. Need to be careful that these armored joints are indeed sound, and if they are just the slightest bit loose, they can continue to kind of reverberate and cause distress at the edge of the overlay. This is an area where we had debonding and kind kind of doing some research on this. It took me a while to kind of to root through this one. Found out that the agency basically had poured through the joint, and then they were going to come back and cut it. Well, they didn't come back for a couple weeks. So you've got a joint that you've closed up, and you've kind of locked it up, but that material's needing to move. So my determination there was I think it basically was a problem with the joint construction there. Generally, the best way to do joints is to form and pour through those, and not pour through and cut them. You want to try to form them. Here another joint area. Looks like we've got very little texturing there. You can't see hardly any grip there for that overlay to grab to. And again, it's at a joint area. This is a silica fume pour that with some fibers in there. And the point I wanted to make here is, again, these adjacent stages of pours are very important areas to get in and make sure you're doing a very good job of cleaning. You want to have good details in these particular areas. What you ideally want to do is over pour your first stage a few inches or so, and then come back and saw cut through that overlay all the way for the length of the bridge, then chip it out. That way you've opened up your surface good, and now you can abrasive blast, and you should apply a bonding grout when you go in and pour that second stage. Here we got an end joint, and I'm thinking some issues with compaction, putting in the asphalt, and that roller maybe getting on the edge of that overlay and possibly causing that to break off the edge there. So just to kind of summarize some of the issues with bonding delamination, I won't read through that list there. I kind of talked about them as we went on. I will kind of highlight one, though, as far as you do want to have a good abrasive blast ahead of your pour, and some agencies will allow high pressure water blasting in lieu of abrasive blasting, but you need to make sure it's an equivalent alternate, and that would be a 7,500 psi water blast or higher. You don't want to go out there with 2,500 psi garage pressure washers. That's not water blasting, and that's not acceptable for preparation. You need high pressure blasting to substitute that for abrasive blasting. And then using good concreting practices is always important. So let's go to probably something that's a lot harder to kind of sort through, and that's cracking with these overlays. And I kind of separated them out here, structural and non-structural. And I don't know if structural is the right term necessarily. It's not something that's going to be structural as far as safety, but more or less structural as far as the material, I guess. Why does concrete crack? Well, for one, we design it to crack. That's why we have reinforcement in there. We put that in there, and it's designed to then take the load because the concrete can't handle that. But we also have restraint with the change in the volume that is occurring with the overlays, and then also just general loss of water through the system. So I kind of lumped this kind of structural cracking into live load stresses, propagation or reflection, thermal cracking, and maybe another way to look at it is kind of full depth cracking here, as opposed to maybe some partial cracking that may be occurring more in a non-structural fashion. And that would be kind of your plastic shrinkage, which is going to occur while that concrete is still wet, drying shrinkage, which occurs when it's drying out. And then there's something also called autogenous cracking, kind of a fancy word there. We don't hear a lot about that, but it's kind of a cracking that's occurring within during the hydration process, where the cement, it's trying to suck in that moisture as much as possible, and it's sucking water and forming capillaries in there that are basically cracks. And the thing about the last two here, autogenous cracking, it occurs over several months. So it's not something that's, you're going to shut off right away. And then your drying shrinkage can go on for a long time. It can go on 6 months, a year, maybe even longer. So you have these two types of shrinkage type cracking things going on there. And that's extremely difficult to try to control. Now, some of the reasons for cracking, placement procedures can be a part of that. The water cement ratio being out of whack, either too high or too low. That's one of the things we see with autogenous cracking is it seems to be more evident when your water cement ratio is less than about 0.4. And you know, the way we design some of these mixes now, we try to go less and less on the water cement. And you know, that has a tendency to kind of play into the hands of the autogenous type cracking. But it's also autogenous type cracking. It seems to be more prevalent with when you're trying to attach to older concrete too. You want to make sure you're pouring in favorable conditions, exposing the substrate concrete. Not properly saturating your exposed concrete can be an issue. Issues with vibration, vibrating of the concrete itself, delays in covering the concrete, and really curing is probably the big thing. Probably 9 out of 10 times that you can probably trace your issues back to the curing process that you're using and not properly curing. So just some of the things you'd see out there. If you're seeing more straight line, longitudinal, transverse, diagonal even, especially on skewed structures, you know, these are probably going to be more structural related to your material. But even at that, your change in volume is kind of figured in there as well. Here with some longitudinal cracking. Notice right in the wheel line. So kind of leads to believe there's something going on with the loading in particular on this particular bridge. This is one I've been kind of struggling with, just a lot of random cracking near the stage construction line. Haven't had a lot of data to go off of here, but I'd be kind of curious to see which stage was poured first, which one was second, and then was there something in the stage 2 preparation, such as the milling, that may have caused some vibration or something to occur in the adjacent section there. Also could be some infiltration of water somewhere under there too, even. Again, just some stray cracks. These are the ones that get difficult to kind of sort out and figure out what's causing the problems. So this particular bridge here, we're near the end joint. Kind of a discoloration in there kind of makes you believe maybe there's something going on with the water cement ratio in there. Maybe it's kind of dry. It almost looks like a plastic type of shrinkage cracking maybe taking place there. This is a pretty severe form of plastic cracking. And a lot of your plastic cracking, we can kind of overcome that with handling the evaporation rate. And that's something that's very important to kind of get a handle on out there. So what is evaporation rate? And what it is as your concrete is trying to hydrate, it's producing a bleed water. That bleed water is evaporating off your surface faster than that concrete's able to produce it, then it's likely to be able to cause some plastic cracking on you. And there is a way to handle this, and that's through ACI chart that they have out there. Just to kind of walk you through the steps here. We're coming in on the left side of the chart in that upper left portion there. And just as an example, we're taking a 65-degree air temperature, and we're going to go up and try to find where does that intersect with regard to the relative humidity. In this case, 40%. You're going to horizontally project over to what your concrete temperature is. In this particular case, we say 60 degrees. And then you come down to the wind speed at 25 degrees, and you're able to determine that your evaporation rate is measured at 0.12 pounds per square foot per hour. Typically, if you are at 0.15 or more, we would expect plastic cracking. Some of these concrete overlays, though, are a little more temperamental. Latex, most states will kind of limit that at about 0.1, but silica fumes are even lower most of the time. They're usually down at about 0.05. But kind of the thing to notice is if you can kind of control this a little bit, it makes a big difference. For instance, if your concrete temperature here would have been 70 degrees instead of 60, you'd be looking at about a 0.3 as far as your evaporation rate. So your concrete temperature does matter out there. You want to try to lower that as much as you can. You want to pour it, when the wind speed's down too. That can be pretty helpful. You can do some things out there to help mitigate that, which would include wind breaks, fogging, a variety of things there that kind of apply and that kind of work with you within the means of that chart to kind of get a good low rate of evaporation. So drying shrinkage, that's going to occur after, we've taken the wet burlap off over time. Now that water, the inside of your concrete is going to be more moist as it starts to dry out, and it's going to continue to suck water out as it needs to help with that hydration process. I wanted to touch on this one here. This was a pour that we actually had a little research project done on. You can see a lot of random pattern cracking, and pulled some cores. We're able to determine kind of the depth of cracking. You can see it's partway down in the overlay. You'll notice the overlay thickness, though, is pretty thick at 3.39 inches, and that's another thing that can kind of play into your cracking. Is the deeper these overlays get, the more prone they are to cracking, and you have a lot more volume to work with as far as water being sucked down in there. But you don't need to be able to read all this. The point I wanted to make here was the petrographer and the person doing the study basically came up with several possibilities. So even the person doing the study could, they're not sure exactly what is the root cause there. But a lot of the things I mentioned there are kind of included in this particular report. But the bottom line was the concrete itself was good concrete from what they could determine, and was going to provide excellent quality still. So you can have concrete that's cracked. It still provides good long-term quality for you. Here's some cracking, probably related due to some sawing, I'm guessing, joint issue. And this is actually not in the overlay, but in the blockout area. This is some random cracking in an early strength mix, and kind of addressing some of these deficiencies. Some of the structural reflective cracks, they're going to develop over time, most likely through these overlays. Often your drying shrinkage is going to be in the upper limits, and it may or may not be sealable, but you do want to sound and verify you have good overlay bond. And you can do some things like provide some MMA surface sealing, either with just crack pouring or total surface sealing, kind of minimizing cracking, curing. That can't stress that enough. Like I said, mostly all of the problems we see are related to curing. You just have to get good wet burlap out there and on there. And you may think you're doing it right, but you need to get that burlap soaked ahead of time and down and covered and put film on it. And that does a lot to help keep that moisture locked in there. I think longer and narrow is better. On that case study, we kind of determined that also it was a very wide pour. So not only did we have a lot deeper pour than we thought, but it was also very wide. Kind of the summary there. I won't read through all those because I think we're about out of time, aren't we? So, but experienced installers can go a long way to helping you on these jobs. When you have people that know what they're doing, they know what they're producing out there, they do a good job of putting down some good quality overlays for us. And sometimes you have to be lucky, as Columbo would say. Good documentation. You need good documentation to really help you be able to investigate and determine what's going on out there. All right, I'll take a few questions if we have time, or do we?
Pat, what would you say to a state who only does a 4-day wet cure on a silica fuel overlay? Is that enough?
Well, most of them we see are 7 days. I would say are you having problems are you seeing problems on them? I would say that's probably a good indicator to work with. So if you're finding a problem, you want to look at, okay, what could be causes? I would say increase your curing and see if that is making a difference for you. I'd also say make sure they're covering it with film.
Good presentation. We've had all those problems that you mentioned. Curious about, you mentioned forming up joints and stuff, and we've had a problem with workmanship in that the joint's like a drunken sailor and it snaking all over the place. And could you speak to that in terms of the joint working properly?
Well, I mean, as far as you're talking about coming in later and sawing it and getting it, or as far as forming it? The forming, so they're having trouble getting it to form correctly. Wow. Yeah, I don't know why they're not able to form it straight. The other thing you can do is if you do choose to pour across, try to get it pre-grooved before it's going to try to crack for sure. And then you can come back and try to to basically saw it out. That might help. I know it probably helps with the ride and the application too, if they can just go straight across the joint and pour it that way. All right, thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.